Hey everyone, welcome back to the channel Code with AKJ. Today is day 49 of solving Geeks for Geeks problem of the day. And today's problem is subarrays with equal number of occurrences. So the question says here, given an array ARR and two integers say x and y, find the number of subarrays in which the number of occurrences of x is equal to the number of occurrences of y. You are given an array ARR and two integers x and y, and your goal is to find the number of subarrays where the number of occurrences of x is equal to the number of occurrences of y. So let's look at an example here. Here given an array values 1 to 1 and x value is 1 and y value is 2. So in this case the subarrays would be 1 and 2 and 2 and 1, where the number of occurrences of x and y are equal, which is 1 here. There could be an edge case where if x and y or x or y don't even appear in the array. So well, that's perfectly fine. Even subarrays with no occurrences of x and y counts. So for example here, given array 1 to 1 and x values are 4 and 6. As you can see, there are no values 4 and 6 in this given array. So the possible subarrays having same equal number of occurrences of x and y could be all the possible subarrays of the given array, which is 1, 1, 2, 1, 2, 1 and 2, 1. So in this all possible subarrays, the occurrences of both x and y are 0, which is equal. So we consider the value 6, which is the all possible subarrays of given array. So coming to this particular example, here the array is 1 to 1 and x value is 1 and y value is 4. So here the possible subarray having same equal number of occurrences of both 1 and 4 would be 2, where the occurrence of 1 is 0 and occurrence of y is 0. So since they are equal, we can say that we have one possible subarray having same occurrences of x and y. So let's start with the brute force approach. The idea here is simple. We'll iterate over every possible subarray of this given array, and for each subarray we'll count how many times x and y occurs, and if the counts are equal, we'll increase our result count. So let's understand the brute force approach using this particular example. So given array here is 1 to 1 and x value is 1, y value is 2. So the possible subarrays of this given input array would be 1, 2, 1, 1, 2, 2, 1 and 1, 2, 1. So these are the possible subarrays of this given input array, and for every subarray we'll count occurrence of x and y. So here the count of x is 1 and y is 0. Here the count of x is 0, y is 1. Here 1 and 0. Here count of x is 1, count of y is 1. Here count of x is 1, y is 1. Here count of x is 2, y is 1. So from the given subarray counts, we can see that there are two particular subarrays where the count of x and y are equal. So we'll increment our count to 2. And we'll finally return this count after calculating the occurrence of x and y for each subarray. So for this case, our answer would be 2. So here the time complexity would be O of n square, as we are checking each and every subarray, which will take us 2 for loops, and space complexity would be O of 1, as we are not using any data structure here. So let's code this brute force approach. So let's take the size of an array. Let's take the count variable, initially 0. We'll iterate over this array. We'll take two variables, x count and y count, and we'll iterate over the subarrays, and we'll check the count occurrences of x and y. So suppose array of j is equals to x, we'll increment our x count value, and if array of j is equals to y, we'll increment our y count value. So if x count is equals to y count, we'll increment our count variable, and finally we'll return our count variable. So let's compile and run this to check if we have any errors or not. It's working, so let's submit. As you can see, this approach gives us time limit exceeded, as our time complexity here in this case would be O of n square. And let's try to optimize this approach and bring down our time complexity from O of n square to O of n. So while the brute force approach works for smaller arrays, but it's far away from optimal approach for larger arrays. So now let's talk about optimizing this solution. So the key insight here is to track the difference between the occurrences of x and y as we go through the array. So if for two indices I and j, the difference between the occurrences of x and y is the same, then the subarray between I and j has an equal number of x and y. So let's break this down. We'll maintain a variable diff which keeps track of the difference between the number of occurrences of x and y while iterating through the array. So we'll also use a hash map to show how many times each diff value has been encountered so far. So if the same diff value appears at two different points I and j in the array, that means there is a subarray between these 2 points where the number of occurrences of x is equals to the number of occurrences of y. So let's dry run with an example and then we'll later on move on to the code. So let's dry run this approach using this example. I have taken a map here, the array with values 1 to 1 and x values 1 and y values 2. So initially we'll take a variable diff which will keep track of the difference between the number of occurrences of x and y, and we'll also take a answer variable or result variable which will store the number of subarrays with equal number of occurrences of x and y. So let's start iterating over this array. So initially we'll start from index 0. Here, since we observed the value is equals to x value, we'll increment our diff value from 0 to 1. Diff value would be 0, so we'll map the sum diff with 1. So again, we'll start iterating over this array. Since we found a x value, we'll increment our diff value with 1, and we'll check whether this sum is already being encountered in our array or not using our map. So since there is no value being mapped over this, so we'll map this value with 1. So we'll again move this index to the next value. So here what we'll do is when we encounter x value, we'll increment our diff value with 1, and when we encounter y value, we'll decrement our diff value with -1. This is because since the occurrences of x and y value becomes equal, the total sum here can be 0. So here, so after moving an index from 0 to 1, we have encountered y value, so we'll deduct 1 from diff value, and we'll again check whether we encountered this value in our array or not using our hash map. As you can see, the value is already being encountered, which means there's a particular subarray in this given array at this point I, where the number of occurrences of x and y are equal. So in this case, we'll add our result variable with our maps value, which is 0 plus 1 equals to 1. So again, we'll move I value to the next index here. Since the current array of I is equals to x, we'll increment our diff value to 1. And again, we'll check whether this value is already being encountered in our array or not using our hash map. As you can see, there's already a map value which is being mapped with a value 1. So we'll increment our result variable with its frequency, which is 1 plus 1. So after iterating over this whole array, we have found two particular subarrays having equal number of occurrences of x and y. And finally, after finishing our iteration, we'll return our result variable. So in this case, our answer would be 2. So let's take another example. 1, 2, 1, 1, 2 with x value 1 and y value 2. So let's take a bigger input array and let's again take a map and initialize the diff values 0 with 1. So we'll take a variable diff and result res, which would be initially 0. So we'll start from index 0. Since we get value equals to x, we'll increment 1 and we'll map this value in our map. Again, we'll move on to the next index. Since it is equals to y, we'll decrement it with 0. And since we already have a map of value 0, we'll add this frequency to our result variable, which is plus 1 equals to 1. And again, we'll move this index to the next index. Since we encountered another value which is equals to 1, we'll increment it with 1 and we'll check. So since it already has mapping, so we'll increment our result variable with its frequency, which is 1. Now the answer is 2. So again, we'll move on to the next index. So here the diff value is 2. So since there is no mapping here, so we'll map this value in our map. Again, we'll move index to the next value and we'll decrement our diff value from 2 to 1. So we'll check. Since 1 has a mapping, we'll again add our result value with its frequency 1, which will give us answer 3. So we have completed iteration over this array as our index I moved out of the size of array. So here we'll stop our operation, and here in this case we got our result variable as 3, which means we have totally 3 subarrays having equal number of occurrences of x and y in this given input array. So in this way our optimal approach works. So let's code this approach. So here's the code for the optimal approach. Here I have taken the size of an array, I have taken an unordered map, I have taken two variables diff and result, which would be initially 0. I have initialized the diff value map with 0 with 1. So I have iterated over this array and I have checked the occurrences of the x and y. So if it is x, I'll increment the diff value with 1, and if it is y, I'll decrement the diff value with -1. So in case if the current diff has been seen before, it means there's a subarray with equal number of x and y. So I will add the frequency of that particular diff value to our result variable. And if not, I'll increment that particular diff value in our map. And finally, after iterating over whole array, we'll return our result variable. So let's compile and run this. So let's submit. As you can see, this problem got accepted successfully. So here's the time complexity is O of n, which is a huge improvement from our brute force solution, which takes O of n square as time complexity. So this is because we only traverse the array once and we used a hash map to efficiently track differences. So here the space complexity would be O of n as we are using a hash map. So let's quickly compare these two approaches. So the brute force approach is simple to understand and implement, but has a time complexity of O of n square. Works fine for smaller arrays but can be inefficient for larger ones. And coming to the optimized approach, a more advanced method using the concept of difference and hash maps to track occurrences, reducing our time complexity to O of n. And that's it for today's video. We have gone from a simple brute force approach to a highly efficient solution for finding the subarray with equal occurrences of two integers. So if you enjoyed this video or found it helpful, make sure to like and subscribe to the channel for more coding tutorials like this. And let me know in the comments if you have any questions or suggestions for future problems. Thanks for watching, and I'll see you in the next one.